Yeah, welcome to part 2 of Geography 10 GIS. And we are following along with the GIS Commons, which we're using as kind of our guide or textbook. So I'd like to acknowledge that and also to acknowledge them for some of the concepts and also some of the graphics as well that we'll use for the presentation. Okay, so we're in chapter 2 of the GIS Commons, and this is sort of the framework that we're going to use to structure our lectures. We're covering part 2 today, which is GIS Input. Last time was chapter 1, an introduction to the major concepts. And then now we're going to talk about getting information into a GIS. Now, and I like the way that it's structured. It makes it easier to kind of formulate something to lecture around. And part 1 is what are the 3 components of getting data into a GIS? It's database design, data acquisition, data capture, and we'll look at those individually. But first, database design. What this really means is you really have to kind of structure what it is that you're going to, the type of, you have to structure what you're going to do and understand what your needs are before you can go out and get the things that you need. So designing what your project is going to be, what the data should look like that you're going to analyze will be of major benefit before you go out and looking for data. And at the very least, you need to have some idea of the type of data you need. Otherwise, you're just sort of randomly looking at things, but and hoping for the best. But if you have a more targeted approach where, let's say you're studying trees, and so you look for tree data, and if you need to know something about trees, such as their height, that you know to look for tree data that includes heights, and so on, or whatever it is for whatever it is you're studying. Data acquisition is where you get data from existing sources, and this seems to be the most common nowadays anyway. It seems to be the most common way to go, is to identify, because there are so many different data sources out there that oftentimes you can find data, at least data to start with, that were created by someone else, by a government agency, or even private companies, non-governmental organizations, or what have you. And then lastly, where you need to, you could also capture data. You could be the primary source. You could capture data from maps by scanning maps and digitizing them, by collecting it in the field, and so on. So let's start with part 1, GIS database design. You need to, these are some things that you need to have in mind when you're designing what your data is going to look like. What are the key features that you need to include in your analysis? Like I said, if you're studying tree heights for individual tree locations, you need to know that find some data with trees as your key feature. If you're studying soils, you need soils. If you're studying rents, you need some type of real estate data, so on. What is the project scale and extent? How wide of an area are we covering, or how extensive an area are we covering? How zoomed are in? How detailed do we need it versus how detailed do we need it? Can we get away with something very coarse level, or do we need highly detailed data? We need to think about the attributes that we'll need and how they're encoded. We'll talk about that in more detail. And then lastly, details like, what do we need for a base map? Can we just use something that's built into our software, or do we need to have something else that really helps the reader understand the maps? And also, what coordinate systems do we need to use? That's another consideration. Although with many of the modern software we use, these last 2 things are pretty well taken care of by the system, that a lot of the defaults and available base maps seem to cover our needs quite well. But it can't help you with going out and getting the data that you really need. That's not an easy thing to automate. So key features. So last week we talked about spatial questions, questions where you formulate to help guide you in the process of bringing data into a GIS, analyzing it, and presenting it. And so as we move from the question, we need to move to more details, like, okay, what are the features that we'll need to bring us to the next step of analysis and presentation. So how much in the end, what kind of GIS features do you need? We already mentioned some examples. How much detail do you need? Is a course level data, like if you're looking at vegetation, would a vegetation map that covers the whole United States, but at a very broad level, meet your needs? Or do you need something that's very detailed and specific for one particular area? Now, one thing about that, my recommendation, and many others as well, get as much detail as is practical, meaning, working with data that's much more detailed is going to consume resources, and it's going to consume more time as well. But you can always generalize that data into something less detailed, but you can't go the other way around. If you start with less detailed data, you can't magically enhance that into more detailed data. So you need to start with as detailed as you can get away with, basically. Other things to think about: how much, what is the project area? Do I have data that covers that entire area, or do we need to have, data from one part and then look for a separate data set for a separate part because one set doesn't cover it? And we need to look at the scale of the data. And again, this is where you look at scale is, how detailed it is. How zoomed in is one scale and zoomed out is a different scale. And when data is created, it can be created at a regional level, like the whole United States, or sometimes it's created at a very local level. And again, it's better to start with more detail if that's practical, and then you can generalize that to less detailed as you need to. And speaking of scale, not just spatial scale, you should also think about temporal scale. Are you looking at the most recent data that you can have, or do you want to study how things have changed over time? Is the data that you're looking at out of date? You need to kind of think about when the data was captured and if that is still applicable to what you're studying. And beyond just the location information, you also need to consider the attribute data. The attributes are the database records that go along with the spatial data. So again, if you're studying trees and you want to know things about the average height of trees in a particular area, you need to find or develop attributes for tree height, for example. Or if you need to know if you want to study the pH of soil, you need to somehow get something that will give you pH information. That would, whatever. It's one thing if you have soil boundaries, but if they don't have anything that can tell you anything about the pH of the soil, it's not as helpful, or not really helpful. So, and some things can be calculated in GIS too, like if you need to calculate the area of each polygon, the GIS can it's a snap for the GIS to calculate that as an attribute. If you need to calculate the lengths of a set of lines, GIS can calculate that. It can calculate the X and the Y coordinates of points, or it can calculate the X and Y coordinates of the centers of polygons, things of that nature. And when you're thinking about attribute, you should also give consideration to how you store attribute information. They can be stored in different ways, as text, as numbers, time, etc. And when it comes to numerical data, you might think there's some consideration of what is it that you're trying to include as numbers. Nominal data is just numbers. So in this example of information from a race, the runner ID, it's a number, but it doesn't have any practical meaning as a number. Meaning it's just like a name. You might as well just have the person's name there. It's just an identifier. 143 isn't 10 times better than 14. It's just different numbers. It's just nominal, like a name. Ordinal is in a ranked order. So first, second, third, fourth, so numbered in a particular order. Interval is a value, but it doesn't have it's not based on 0. So it's like a time that a person finished. You didn't start at 0 time. You started at whatever time this race started, but this is like the time, an interval since a different interval. So whereas ratio would be the race time, here this is starting at 0. So you entered at 10:10, and that represents 2 hours and 30 minutes. And I'll also have we'll have a separate, for some of this stuff, we'll get into more detail in a different video. Base map considerations. For what the information that you're trying to convey, are there particular things that need to be included in the background? For example, administrative boundaries. If you are working on a project related to, let's say, water districts, do water districts need to be displayed on the map? Or if you need to include county boundaries or urban boundaries, do you need to show roads or highways for reference? Do you need to have, are there certain place names that need to be included for reference? So you have to think about your audience. If you're developing something, say for the U.S. Fish and Wildlife Service, then you would want to include, say, U.S. Fish and Wildlife Service refuge boundaries on the map, because that might be meaningful to them because they administer those areas. So it depends on your audience. And like I mentioned, the software, for example, ArcGIS Pro, and there are, even in the open source versions, you can add things like a map base that looks kind of like Google Maps or OpenStreetMap. And these are kind of pre-made base maps that you can just sort of, put into your project. Makes your life a whole lot easier than trying to do this stuff from scratch. But if you had to, you could actually find layers for roads and cities and aerial imagery and what have you, and you could create your own base map. Or on the other hand, you could maybe start with one of the pre-made base maps and then add some other layers that you find necessary to enhance that, like administrative boundaries, for example, that aren't included on the base map. And just a side note, kind of back in the older times when you didn't have these pre-canned base maps, creating your own base map was a lot of work, and it was probably more work than was really necessary. After a while, you would get smart about it, and you would reuse your base map, all the that you had created. But for people just starting out, this is a real time saver to be able to just pop in a base map rather than starting with a blank screen and you having to create your own. And projection and coordinate systems and datum, we'll get into the more detail on things like datums later on and how to troubleshoot. In the introduction to the introduction lecture, we talked a little bit about coordinate systems like latitude and longitude versus projected coordinate systems, equal area versus conformal, where one preserves the correct size, one preserves the correct shape, and then you can have compromised projections that kind of do both. And some of these may depend on the scale that you're using. It may be that a map like this one on the right, which would be that like a Mercator projection that doesn't properly represent size as well. But if you're zoomed into a city, it works perfectly fine. The default is pretty reasonable in software like ArcGIS Pro or Quantum GIS, that what it'll do is when you first add data, it'll use that first data set as your default projection. And that seems to be fairly reasonable. But one thing I will point out, though, that sometimes if your first data in is in latitude and longitude, then it'll create something like this on the left where things look a little stretched out, because latitude and longitude are not exactly an X and Y grid. It's really the distance and the width in longitude is actually thinner than it is in latitude because of the the latitude is kind of getting skinnier and skinnier as you get towards the North Pole. So the end result is if you have a map like on the left that looks kind of stretched out, you can just pick a different coordinate system that's projected, and that will fix that issue. Because this looks kind of like you took the map and kind of pulled the, especially at the top looks really stretched out and unrealistic compared to this one on the right. This one is in latitude, longitude, or decimal degrees. This one is in a projected coordinate system, an equal area projected coordinate system, as it so happens to be.